and Happy New Year's to anyone watching this live. I decided that I would redo parts of the tutorial series on how to create the DirectX application from scratch. Uh, since we ended up having some different issues, and yeah, during the live stream I also accidentally flashed the screen, so I decided to pull that live stream as well. That means that the GitHub repo here is has been changed a bit. I did a commit with some faulty code, and yeah, I decided to pull that. So we're back at the state with the uh, separate shadow pipeline state. Yeah, there were some issues in that episode. Also, I will be changing the project outline here. I'll of course comment on that in the first video that we do. And I figured that we might as well just fix some bugs that were lying around in the application. So yeah, we'll do some bug fixes. And do some stuff, and I think the project will be done today, because in the meantime I fixed the bugs, but yeah, I didn't show that on stream, and I didn't know why things were buggy when I did the stream yesterday, and I didn't have the time to fix it, but now I both understand why we had bugs and how to fix them, so yeah. This stream was scheduled to be, I don't know why it always uh, specifies the category as entertainment. Let me just swap that. Anyway, maybe I can do some settings. Uh, yeah, I'm a bit tired today. Haven't gotten much sleep, so hopefully it doesn't affect the streaming experience on your end. Um, but yeah, I'll just wait for anyone who wants to watch this live and who might be late, and then I'll get going. As per usual, I'll do offline recordings. Let's see. Let me browse through. When did we commit that episode? We committed it yesterday. Around 10 a.m. Oh yeah, we did. Yeah, let me just walk through the bugs. Okay. All video plan. Uh, New video plan. Episode 25. Bug fixes. Shaders. D12 resource. Custom. Constructors. Move/copy. And then make sure resetting pointers, release resources properly, and then we will do episode 26. Implement shadows using shaders and shadow pipeline. And then episode 27 will be implement time step and some basic animations. So that's the outline for the coming episodes. Yeah. We should just get going, I guess. Let's see. Let me swap this window to our chat so I'll see whenever someone posts there. All right, I think I should start the next episode. Okay, I'll start the recording. Hi and welcome to the next video in our video series on how to do your first DirectX application in C++ from scratch. Yes, in the last episode we worked on a pipeline which we would use for our shadows. It was a transparent pipeline that had a blending operation and some stenciling, and yeah, we did some work on that, but we're not using it for anything. We will do a new plan instead of the old video plan, since some time has passed, and I actually did a live stream yesterday that followed up on this, but it ended up being a bit buggy, and I decided to redo the episodes so that you don't have to bother with bugs. But that means that this episode will be changed a bit. We will, of course, do shadow implementations when relevant, but we will fix some small bugs that are in our um, system right now. If you're watching this in the future, um, or if you're watching this, you might see that there has been some commits. In the meantime, I've reverted back to this episode here. So this code version is the one that we're using in this live stream. Just be mindful of that. Okay, so we had a problem that our D12 resources weren't being allocated properly when the vectors underlying them got resized. We kind of made a temporary fix for that by making sure that our vectors never resize, but in general, that's not how we would like to handle it. So the problem pertains to the way that vectors resize, since they do either a move or copy constructor when they reallocate the new objects, because they need to find a new place for them in the heap, since they need more heap memory. They call a move or copy constructor, but that's just a defaultly implemented constructor, and since we have a member variable that's a pointer, that usually leads to a lot of trouble. So let's fix that. I don't think that for this project here, a resource should be copyable per se, which means that we will simply delete the copy and copy assign constructors. Let's see, let me spell this correctly. Which these statements make sure that we do. So let's do that. We delete them. Right now, our program won't compile because we have not supplied a method to actually reallocate the resources. Then it says you've deleted the copy constructor. I don't know what to do. So we need to reference our move constructor that always uses a temporary. So and should be defined as no except because it shouldn't throw. It should just fail in case. And we will use a custom move operator slash constructor instead. So let's see if the other object that we're moving from has a memory pointer set, it means that it has been mapped, because when we call this function, we check if the memory pointer isn't set, and we map it. We don't do this anywhere else in our application, so that means that the other resource here could be properly unmapped. Then if the other actually has an interface, it will probably have that. We would like to swap that underlying interface pointer with our own here in this object here. Then if we actually got a pointer to an interface and the other had that memory allocation set, we know that this should be mapped. And we want to reference our memory And then the other memory pointer should be reset, so that if the object goes out of scope, when we call the release function here, when it goes out of scope, we check if the memory pointer is set and also if the interface is set, and we unmap. And yeah, so we reset like that. Then we need to do exactly the same, except we will return a dereferenced reference to our object, because we want to pass on a actual object. All right. Now we should be able to actually remove these statements here, the object transforms and the material buffers here, and we shouldn't get any DirectX debug errors when the vectors resize. But I've also stumbled upon another error. It's a classical mistake for me, and that is whenever we call release on this, we also would like to set it to a null pointer, because we released the resource, but the pointer doesn't point to anything anymore. So we need to do that for our shaders whenever we release them. Okay, let's try compiling this, running this, and closing this. Okay, we actually do get a crash here because we're apparently referencing something. So let's try and make sure that the pointer is actually valid. Okay, now no problems, no crashes. Whoops. Let's move this back. GUI, please let me move this back. Where do I? Let's see, layout, window, reset window layout. Yeah, okay. And let's do our, and then our debug area here appeared again. Let's see, do we have any errors? No, but we have some warnings. There's a pipeline and a root signature referenced, but we do not have any errors anymore. So yeah, we fixed the issues. Let's try opening and closing several times, even as fast as possible. Okay, so that seems to be fixed. We only need to call release on our newly created pipeline. So let's do that. Did we actually call it something? Planar shadows. Okay. And then I realize there's a shading error. Let's see. Let's set our light direction here. It points towards the positive z-axis. Let's just reset that and set it to point towards the negative x-axis as well. So that will be a 45-degree directional light that shines down and towards the x-axis. Let's reset our camera here so that we look from the Z-plane. As you can see, or maybe you can't see that actually now. Let's offset. So this slide here doesn't shine correctly on this object here, but it shines correctly on this one. And if you look into the vertex shader here, you will see that our normals here actually gets transformed and thereby translated by the object transform slash world matrix. Normals shouldn't be transformed, they should only, or translated, they should only be rotated. You could do this in several ways. You could ask the shader to discard the parts of the transform that pertains to translation and only take the parts that handle rotation and potentially skewing, even though we are assuming a bit of non-skewed coordinates. We're assuming orthonormal coordinates, but we might not be supplying that. And then you could simply pass in the normal and do like this. And let's see, immediately you see the change. Also, the floor gets shaded properly. So this looks a lot better than our previous setup. So that's an actual bug. So let's fix that. Let's see our shaders here. Well, these are just as is for now because we will handle them in the future episode. And if oh yeah, there's one more bug. In the last episode, I forgot to mention that you would also like to clear the stencil between frames. Otherwise, you just write to the stencil and never clear it, and it will stay the same forever. So yeah, let's fix that. And yeah, I'll explain some setup in the next episode. All right, let's change this back to a light that is just shining down here. And let's set our camera to something that just looks down at an angle. Okay. This would also need a 1 here, since the transform line here always ends with a 1. I'm not sure it actually changed anything, but let's see. That's just, we might actually have a, no, it doesn't move, no. Okay, but that's more proper. Let's set up our floor here so that it is scaled correctly. We will do a Y scale on 1, and then we will simply offset by 2, or maybe even just 1. Yeah. So now we will make sure that the floor is actually at the 0, 0, 0, at least the floor surface, but then we need to actually move these objects up a bit. Let's do some Y offsetting here. There we go. Great stuff. That's it for this episode. Let's just delete this. Let's just delete this, and we will do this, or rather we've done this. So let's save that, and I'll upload the video. Okay, thanks for watching. Hopefully you found this helpful. I hope I explained why there were some minor bugs that in the future would accumulate into some harder to debug problems. So yeah, since I'm doing this mostly during a live stream, bugs are prone, and well, we just need to fix them. And yeah, if they accumulate too heavily, I think it makes sense to redo the episodes. So hopefully you'll feel the same. Um, Feel free to like, comment, or subscribe, and hopefully I'll see you in the next one. And let's do a commit. Part 25, isn't that the right one? Yeah. Bug fixes for creators and resources. And let's do that. Let's upload the video. Uh, and let's see, it will be part of that playlist. Let me just set up. Uh, let's see. All right. I think we got that sorted. Let's immediately get started on the next episode here. Hello and welcome to the next part of this tutorial series on how to do your first DirectX 12 application in C++ from scratch. In the last episode we did some minor bug fixes, and we are now ready to move on to the episode where we actually use our shadows drawing pipeline and do some setup. I explained how I had to redo these episodes due to some bugs that accumulated, and due to some backtracking. I also removed the original live stream since it had severe screen flickering, which I don't think is fair to someone who might have epilepsy. So I decided to remove that and redo parts of the series. All right. What we need to do is to create a shadow material. Since we haven't done that, we've created our floor and box materials. Let's see. So we will simply copy this code here. And we will create an entirely black material that has an transparency. Let's see, we will reset this and we will name it properly. All right, that's basically it since we've created this system here. Next, we want to do some actual shadow casting / calculation. And in order to do that, our pipeline is now set up the same way that our regular object pipeline is set up, with the same root signature and everything. But we of course need to bind it. I don't think we need to change the root signature itself since it's the same for both pipelines, but we need to bind it during our draw calls here. So we will set the pipeline state, and we will take our planner shadows interface here and get a pointer to it. We will next set the command list to register which primitive topology to interpret everything as. I'm actually unsure whether you would need to do that since it's already done up here, but since we flushed the pipeline / changed the pipeline, we might as well. One improvement I also wanted to mention is that we only need to do this once. We don't need to do it every draw call because the past data is the same for every object. Our past data is just our view projection matrix from our camera and our lighting information. So yeah, we don't need to do that. It will be set once, and then the individual constant buffers will be set for each object itself. All right. We want to cast shadows on our floor with our objects here. So let's just for now copy our draw calls. Since it's basically the same right now, the objects will overlap, so I don't suspect that we actually draw anything to our screen here, but it should compile though and do just fine. Let's see. Nope, we do not get any results from this. But if we actually, hi and welcome. Yeah, Happy New Year's. But during our draw calls, we want to bind a different transform for our shadow. We want the lights to shine on the object, and for it to cast a shadow, we have a directional light, so it will cast shadows through each vertex. And kind of like translate it into a plane, since we're doing planar shadows. Since we do planar shadows, we want to display them on a predefined plane. A planar shadow is a shadow that you can see only on one plane. And let me see. That means that we have to project each vertex of our object here onto a predefined plane. These are fairly simple shadows that have some limitations to them, but that's what we will implement in this project. For real projects, you might want to do shadow mapping, which is fairly advanced, and we won't be going through that in this series. But as I've mentioned, to draw a shadow, we will use the vertices for our objects and translate them into a 2D representation on a predefined plane, which will in this case be our floor plane. And in order to do that, we need some transformation matrices that are unique to shadows. That means that we will create some shadow transforms here. We will do this fairly simply. Since we will just mirror our object transforms. And reserve some space and initialize some stuff. First, we want to resize and create empty objects on this series of shadow transforms according to the object transforms vector size. And then we want to initialize every object. We will, of course, initialize it as a constant buffer on our upload heap, since we will do shadows that are possible to update and animate. And we will update them every frame. So we will initialize them, and we will then update them each frame. I think that it's nice when we look up our stuff in terms of debugging inside either RenderDoc or NVIDIA Insight, that we can look up individual buffers and discriminate them between each other. So we will create a wide string here that will be shadow transform buffer, and then we will append a number to it. Let's see. No, std to wide string here, and then our index, and then we will grab the shadow transform here and set the name to our name in C string style. Yeah, and then we will pre-initialize it as a identity matrix. Since we want it to be non-zero, a transform won't work if it's not an identity matrix. Then the shader computations will turn out all zero, and you won't actually be doing any vertex or pixel rendering. So let's see, shadow transforms, and then get CPU. No, get CPU memory here, and then we will simply take our temp data, and then we will write as many bytes as we have to. As you can see here, it's initialized as an identity matrix. So this is the initialization of our shadow matrices. Let's then use these matrices. Let's see, did we actually copy our draw code? Yeah, we did, but only for our two objects here. So we will set our shadow transforms here as our actual transforms. Let's see how this looks so far. Okay, as you can see now, we start to draw something. We probably draw this object with the shadow shader on the other object. It's because the shadow transforms are not real shadow transforms yet. That is why everything looks a bit weird. I'll show you how to actually calculate the shadow transforms. First off, I do think though that we need to change our light a bit so that we will more easily see a shadow cast. Right now this is a 45-degree directional light that shines down towards the negative y-axis and towards the negative x-axis. So that will give us a 45-degree angle, which you might also see from the highlights here. Two sides of the meshes are highlighted. But we will do shadow calculations for each frame. That means that we will do some updating here. Let's scope it so that we can actually kind of segment what's happening, and then we will do a series of draw calls. Let's do draw frame, and we will move all this inside our draw frame scope here. So now we can actually minimize this, and we will of course move this into our update step here. We will update our camera information every frame, and also our light information. Yeah, so DirectX Math actually has a shadow matrix calculator. You can always look up planar shadows matrix, and let's see, does anyone have a yeah, they are for projected shadows which use point lights. Excuse me, let me see. Let's see, directional. Well, they aren't as explanatory as the ones that you might see. Let's see. No, shadow mapping is something different. Maybe does this guy actually show a proper matrix? No. Okay, anyway, somewhere on the internet there is a proper planar shadow matrix. Anyway, we won't bother too much with that. Let's just implement them. So as you saw here, we need to define a plane and a light position. And this function takes in a 4D vector describing the light position. If the last component, i.e. the W component, is 0, the ray from the origin to the light represents a directional light. Remember, it states from the origin to the light. We have a directional light, so it's obviously important that this last component here is 0. But this means that it's not our light direction, but it is the opposite of that. The origin is always 0, 0, and since our light is shining down, given a certain direction, this means from the origin towards the light. The light is um, infinitely far away, but it has a direction. So it's simply the direction that the light is in, which means the opposite of the specified light ray direction. You can also do point light interpretations. That means that the shadows will be cast like it was a point light. You can always look up different lighting situations. As you can see here, this is directional lights. There are so many rays that the projection gets cast according to those rays. A point light, it will have sort of a cone of rays, which means that the perspective on the actual vertices and how to project the shadows are different than a directional light. All right, let's see. But we want to use the DirectX function. We will create a plane here. We will call it plane to cast shadow, and we will simply define it as our floor plane here. I suspect this last component is actually the D value in terms of defining a plane. Let's see, plane vector. Whoops. Plane definition normal. Let's see. Do we have any? Yeah, you can define a plane using its normal and its so-called D component, which means the distance from the origin, signed distance from the origin to the actual plane. But anyway, we won't be specifying a D. We could play around with it because one of the limitations on planar shadows is that if you define your plane without an D, the objects need to be elevated over our actual y equals 0 point, which is why I kind of did this tricky little racing of things and then extended the reach of the floor. You might have not have noticed or known why, but that's the reason why. It's a limitation of the planar shadows. You need to handle the actual definition of the plane and calculation of the shadow matrix. Anyway, we would also like the direction to our lights, which will be our inverse direction, meaning we will call vector negate here on a float that we already have stored. So we will call load float 3, which will return an vector. And we will reference our lights direction vector. So remember, this is the direction that the light rays shine, and this is then the direction to our actual light. Then we will create the actual shadow matrix. Let's see, shadow, and we will pass in our plane, and we will pass in our direction to our light source. And then, since we don't want C buffering / depth buffering issues, we should probably raise our shadows a bit from the floor, which means that we would also like to translate this a bit up on the y-axis. Let's just do a matrix for that, because then we can simply multiply several matrices together and make sure that every operation is done at once as per vector uh, um, vector matrix multiplication rules. Well, then, okay. And then we would, of course, like to create a individual shadow transform for each object. Since we already pre-allocated the buffers themselves, we can simply iterate over all of them. So we would like to update the shadow transform data here. So let's do the same, but we need to do computations on these data here. We will update the transform, and this will be somewhat hacky, because in general you don't want to access the GPU upload heap in a read um, um, read call here on the CPU. We are on the CPU side here, remember. But otherwise you would have to kind of store the object data in a separate vector and then update the actual um, object transforms as well each frame, in case you have changes to them or you animate the objects or something. And then you would just grab that internal vector. For instance, let me show you, if you had alongside this, which actually controls the GPU resources that you shouldn't access, you would have something like a object data vector here, object transforms CPU, and you would for each frame update these accordingly, which means you would also create from them. You would store these in the according vector. We could do that if we wanted to. All right, let's implement it because it's just cleaner. We shouldn't do stupid stuff. So let's do that. We will do our object data here, temp data. We can simply copy from the same place. You could also copy from the vector, but well, it's already on the stack, so might as well just access that. Then we do the same thing here. Let's see, let's kind of segment this together. I think that resetting it to an identity matrix every time is probably a bit more clean here. Even though it's kind of wasteful, we might forget something. Okay. So now these mirror our actual object transforms. We won't update them every frame, excuse me. But now we can access them in a better manner. Let's see. Now that's more clean because this is CPU sided and not GPU sided. So that means that we're not doing something that we're not supposed to. If if you wanted to update these or animate these, you would of course have to do something like this to our object transforms and upload the new data. We're not doing that, but anyway, you want to take the transform for the object and then multiply it by the shadow matrix, meaning that not only do we translate, rotate, skew the object as we should, we will also project it onto our floor plane here using the shadow matrix, and then we will translate it a bit on the y-axis so it doesn't merge with the floor, resulting in depth fighting on the GPU. And that would lead to flickering pixels or yeah, noise in the image. Yeah, so we will basically do that. Upload our shadow matrix here for each object. And let's see how this works out. Okay, we have an issue here. Undeclared identifier. Oh, we haven't included the, well, oh, it's because it's in a namespace, of course. There we go. And as you can see here, we actually get something that looks like a shadow. The problem is that we forgot to bind our draw calls to the correct material. Remember that down here where we do the shadow drawing, we created a separate shadow material that is actually material number 4. And as you can see, we now have shadows. Which should be in relation to our actual light position. Let's see. I do think this is not right though. Let's see. Anyway, let's try moving the shadows a bit, and let's try moving this object also, moving it a bit further out and then elevating it. Yeah, we change the lights. And this might actually be all right. Let's see. I don't know why it doesn't affect it, but this is not actually correct shader code. Let me just redo it here. So aren't we using the correct shaders? Well, we are. Maybe it's due to versioning. I don't know how. Since these aren't included in the project, I might end up in a state where I have a different shader. Anyway, let me just show you how the correct vertex shader for the planar shadows is supposed to be. Let's take our input position here. No, let's not use this at all, actually. let's just swap this. And then we want to create a world projection position because the shadow matrix is actually a projection onto a plane. And then when we want to pass our screen space coordinates, we will simply use our appropriate position here. Since this information here, when you transform the vertices by the shadow matrix at the W position of this vector here, it contains the perspective correction, which means that if you only use the first 3 components, you would end up with an error. All right. Yeah, I think due to versioning and stuff like that, I might have a different state locally. Anyway, this is the correct shader. The pixel shader is fine here. And as you can see, we have shadows, which is pretty great. Let's try doing a, let's see, do we actually translate this? Well, one last issue, I think, in terms of the faces here is that we would like to normalize this. As you can see outside in our CPU-sided code here, yeah, that makes the lighting a bit more reasonable. Let's see here. If you see, whoops, I missed a parenthesis here. As you can see, things get a bit more intense because the values actually end up being higher. So this is an adjustment that is more proper. Not a bug per se. It depends on what you want to do. Anyway, our lights here. Get rendered with shadows casting. As you can see, objects can't cast shadows on each other with planar lighting, but that's just another limitation of that. If you had another wall, you could, of course, do a shadow pass with each object projected on the wall. But yeah, that's basically it for this episode. Let me revert back the camera here, or rather the lighting here, and let's set it to something like this. Well, that looks great. We could also do something like, well, we will do a light that's an angle here. Oh, we already did that. And we can, of course, see that this only casts a shadow for the floating object. Let's move the camera a bit back so that we can see things more clearly. Yeah, you can now see that the object is floating in the air more clearly. Let's do a bit lower position on the object. There we go. Great stuff. Maybe we got a bit far out on our camera here. Let's do that as the last change. Hopefully you found this helpful, inspirational, or entertaining. If you did, feel free to comment, like, or subscribe. Yeah, in the next episode we will do some do some stuff in terms of implementing a timer function. We did planar shadows here, and um, doing some basic animations and stuff like that. So it will not be as much of an episode in terms of the actual rendering stuff, but yeah, we will see how to couple things together into a small project that does some animation. Yeah, great stuff. Hopefully I'll see you in the next one. Thanks for watching. And oh, I forgot. There were some questions here in the chat. Do you plan on implementing I'm GUI anytime soon? No. Linking up to different libraries is more of a programming tutorial series. This is on the DirectX side of things. So that's an entirely different topic, and we won't be covering that. The scope of this series is to get you up and running in terms of using DirectX 12, and it's a beginner series, so I'll leave it up to you to do those kind of implementations in your own projects. Just remember that immediate mode rendering can be coupled to your rendering API, which means that ImGUI can use DirectX 12 to do its rendering. All right, I think that was it. Hopefully I'll see you around. Bye-bye. Let's see. Let's upload that. Add it to the series here. Mm. Mm. Am I in trouble in terms of my internet connection here? No, everything should be fine. So it's probably YouTube that is slow. Let's commit the changes. Part 26, drawing planar shadows. And we want to save and commit and update that. Let's see. I just want to check the commit history. Let's see, view the project as this state here. Let's see, in your application shaders, shadow, vertex shader. Yeah, I'd use that one, but what about the let me see if I simply truncate the trailer there. Let me see what actually happens. Let's set that to 1. Whoops. Maybe if I clean my solution here. And do, oh, maybe it doesn't show if I do not have a weird camera or lighting angle. Well, this actually just works. Let's set it to 0. Well, yeah, that doesn't work. I might also have had some other issues inside. Oh yeah, now I forgot. It's because I also chose to not offset these. As you can see here, that splits the shadow. If we kinda redo this or set it to just 1. Well, anyway, I had some bugs, which are now not present. Okay. Let me just All right, great stuff, great stuff. We're up and running here. Should I do the last video and just get done with it? Yeah, I think I'll just get done with it because then we are at a appropriate end for this tutorial series. Oh, I forgot to change back the object here. Okay. Okay, I'll do that, and then I'll probably consider some toon shading effects. Yeah, let's get going. Okay, I'll start the next episode. In just a minute. Okay, let's see. Okay, I'll start the recording now. Hi, and welcome to the tutorial series on how to build your first DirectX 12 application in C++. During our last episode, we implemented our planar shadows and got rendering up and running for that. That means that now we have a system with materials, we have lighting, we have shadows, but we do not have any system that can handle simulations, which is usually something that you want to do in terms of DirectX 12 applications. Most of them do some sort of real-time stuff, and you might want access to a so-called time step. A time step is basically a clock that tells you how long time passed since your last um, update call. So let's do that. We will create a system here. Oh, that is probably why. Okay, I actually uploaded the system itself, but the application probably doesn't have a system. Okay, and that's because I had to redo some episodes. So let me just show you what I implemented. Usually I don't do things like this, but since this is a redo of a previous episode because of some problems, let me just show you. The time step is a class that we export to our API, and it has a constructor and it has a tick function. It stores a time point internally that it updates. And the actual implementation is once we create a time step class, we set the clock to the internal clock to whenever it was created. Whenever we call tick, we store the last time recorded in a temporary. We update the current time stored in the class, and then we compare, or rather calculate the differences, and then we count the amount of seconds that or I think it's microseconds that went on since the last call to check, or since the object was created. So in our application here, we will include a time step, which we will create. Let's see, timer, time step, time step system, and it will immediately be initialized whenever we create it. But in our application here, we want to be able to actually set it. So we will tell the system to tick every frame, and we will also store it as a variable called timestep. We would like to pass this to our renderer. So let's change this to take a constant float timestep, and we simply pass it along into our update draw method here. So now our renderer actually knows how long time passed since our previous time step. Okay. We would like to be able to do computations for our different components. For instance, if we wanted to animate a light that travels what do you call it? Maybe we want a traveling light that is somewhat like a sun that goes from the east to the west. We could create a simple animation here. That would take a float. Let's say that we want a light cycle that starts at midday, and this ranges from 0.0 to 1.1, so it's normalized here. We will set our lights to be directly at midday here, so that our computations fit our initial state. And then we will do some calculations here. We want to, let's do a separate area, simulation. And we want something like an increment here that we calculate by a value that we multiply by our time step. And then if our light cycle here is equal to or greater than our maximum here, we reset it. And afterwards we increment it by our increment value. This means that each frame we update our light cycle and we wrap it to the interval 0, to 1. That will give an indication on where we are in the life cycle of, or rather the light cycle of this animation, meaning that we know if we are at east or west. Since the rotation of the sun is, we will handle it by a call to the so-called XM matrix rotation around a normalized axis. Takes in radians, and since we start at midday, we know that our rotation will be either, if we do only the day part, our rotation will be limited to 180 degrees, meaning that the 0 point is equal to the sun is rising in, well, I need to make sure that I don't mess this up. It's rising in the east, of course, meaning that it would rise over here if we expect us to be aligned with the compass, with a north forward being the north direction. So since we're starting at midday, east would be one part of the actual rotation, and west would be the opposite part of the rotation in terms of the angle. Again, we're starting at midday. So since we would need positive and negative angles, let's create a so-called clamped cycle that is equal to our light cycle times 2 minus 1. This will set it between -1 and 1, with 0, 0 being midday. We also want some sort of max rotation in the endpoints of this cycle here. Let's do maybe the half of pi as a max rotation, and let's convert that into an actual rotation, where we take our max rotation and use our clamped cycle here to calculate how much we rotate. And then we want to use this method here to create a matrix that we can multiply our light vector with to get the actual rotation. So we need to store a matrix here, rotation matrix, which we will then create from the XM matrix rotation normal, and we will pass in the axis that we will rotate around. We will rotate around the axis that the sun will rotate around. From our viewpoint here, it will be our north-south axis, which means the z-axis. And we pass in the actual rotation here, and we calculate the rotation. Since this is a simulation that happens every frame, we calculate the new position of our lights every frame. If we were to save this new position, when we of course multiply the light vector direction vector with this, we would get an increasing amount of rotation, and we would get a lot of flickering. So we want to calculate something that is our actual or frame-based light direction. Let's see, it will of course frame light direction, which will initially, no, which we will simply calculate directly here. We will transform this vector 3 by, first we need to load it, of course, as a lights vector here, or rather a vectorized component. So we access our light direction here. And then we want to pass in our rotation matrix. Rotation matrix. And this is our frame-based light direction. We want to store this in a, well, now we actually want to update the position here inside the shaders, because our light position will have changed, but we don't want to overwrite this. So we actually need a sort of light structure here. Current frame lights, which we will initialize as our current light, but we will update the direction here by storing our newly created load here. Okay, we actually just call that. Let's see, our current frame lights direction, of course a reference, and then we pass in the frame light direction here vector, and we just delete this. That also means that we will not be copying this anymore. We will be copying this. Also, we will not be using this light direction for the shadows. We will be using this. And this should actually be quite all right. Let's see, we have a problem somewhere. Oh, let's see, maybe I need to, okay. Maybe I need to add them to the project again, because it doesn't find them. It's due to some linker error. Let's see if I look at the local branch here inside our source code system timers. We do have the files. Can I add them, exclude from project? Oh, we're in a Let's see. And how do I add it to the GitHub stuff so that it, well, right now it's not included in the project, so at least on the version that we have here. Let's see, maybe if I open and close the project. Let me just see. Whoops, that's opening in the wrong IDE. Okay, now it registers that this has not been included. Let's see, does our change still appear? Yeah, everything looks fine. Let's include it in the project here. And let's see if everything builds. As you can see, we now have animated shadows. And maybe we wanted to create some longer cycle. I don't know how the lighting is handled when the sun actually is below the plane here. Let's see. That will be interesting. Well, nothing happens. We have darkness. And sometime soon we will have some shadows here. Okay, we have a full day-night life cycle. And of course, shadows move a lot more during the last parts of the day, where the angle between our objects kind of like get kind of parallel, at least in terms of projecting the vertices on the plane. Anyway, I think this was a nice little bite-sized episode on how to do a bit of simple simulation and animation. Our scene here looks quite nicely. You could of course do improvements to the toon shader. Usually people do some more interesting shadow calculations on the actual faces of the objects. Yeah. You would basically write a more interesting pixel shader for your faces here. I see people sampling translating this value here into a gradient. which kind of like maps to either light or dark. Yeah. But I guess you could play around with, yeah, however you'd like your shaders. All right. I think that was it for this whole series. Um, I hope you liked it and learned something from it. Um, it was nice for me to do, even though the shadow computations were something that I had to understand. I haven't done shadows as planar shadows before, so that was definitely a learning experience for me. But yeah, I think this project turned out quite nicely. It of course had to be limited in scope for us to be able to do something with it and have an achievable goal. As mentioned during the series here, if you have any specific requests in terms of tutorials, um, you are free to uh, request them, especially in the comment section down below. But for me to do another video series on a certain topic and creating a tutorial on different stuff, there would need to be a fairly large audience for that, and um, you might not realize that sometimes the scope of things that you request for the tutorial series might be fairly extensive, so that will also be somewhat of a limitation to our yeah, whatever I'll do here in this series. Of course, I'll do more advanced stuff on my regular live streaming series. Um, I will implement shadow mapping and probably some physics-based rendering and bloom effects and other different stuff on the live stream, but it's not a tutorial series. It's more of a live coding series, and I might even do offline work if I'm trying to really focus. But yeah, at least some topics will be discussed there, and you can always join the stream, hang out, ask questions, and interact if you want to. So let's call it a wrap on this video series. Thank you for dropping by, and as I've mentioned, feel free to interact with the content and subscribe. Also, if you find any of my work helpful, feel free to support the channel. You'll know how if you check out the description. All right. Stay strong, stay healthy, and thank you very much. Bye bye. As for the live stream here, I'll make the commit and upload the episode, and I'll do some work here on the channel stuff. Let's see. Let's upload the video. And do the title here. Let's see. 27 episodes. Let me just do the commit part 27, a timer, and a basic animation. There we go. There we go. So that was it. Now I'll do some basic work here on creating a nice thumbnail for our video series. The stream will not be containing any more tutorial stuff, so yeah, we will just be hanging out. I also need a bathroom break, so let's see. I won't be committing any more changes. Let's see, can I create a new branch? New branch. Private branch. All right. So now let me see. Can I hide branches on? Well, since we haven't committed anything, I probably can't yet. But yeah. All right, I'll do that bathroom break, and then I'll be back. Let's see. Let's remove this since we're not doing a tutorial anymore. Let's also change from no. Subscriber mode is still fine. And let me just figure out GitHub make branch private. Okay. Essentially, I can't make a private branch here. Well, I'll just never push the stuff. Um, okay. But let's add a existing item here. Out here I have a header file and I also want a CPP file for our object loader. And let's just move these files. I can't do that or what? Why can't I move those files? Okay. Let's remove them. Remove. Oh, let's see. Let's check out into that. Let's delete it. The old branch here. Okay. And let me just not do any more commits. Okay. I'll add in my OBJ reader. Why can't I move that? Oh, it's because it's outside the project probably. Add an existing item. Let's just move it into the vendor folder here. Okay, let's refresh. Let's include it. Application, we don't need that. Let's do the renderer API. And inside our OBJ reader, we did some stuff here. And let's create um, a void load resources, which will be a private function, which are which will contain all of this. And we will set the lights here as the first initialization. And we of course want to call load resources after initialization, so this should still be fine. Yeah. Also in the initialization here, I think we can initialize this as a, yeah, we could initialize those, but we don't care. Let's also move all of this. Also in here, we will create, do we have any models? We have the cube model, right? Yeah, we do. Okay. Let's create an obj reader. Did I specify it? Oh, I haven't included it. Include the vendor obj reader here. File reader, model reader, loader. Let's just call it that. Model loader, read file, models, cube dot obj. Let's see, does this compile? We have a problem here. G indices undeclared identifier. Did we remove that? Oh, it's because it's not defined in the correct order. Let's just move this up here. And move this up here also. These are temporary, we won't be using them, but so we will of we will create some vertices, obj vertices, and we will create some uint 32s, obj indices, and then we will create 3 vectors uint 32, mesh v offset, and then mesh I offsets. Okay, and we will start our model parsing here. And for whatever amount of vertices we calculated from the obj file, we will pass it. Let's see, vertex temp vex temp vex equals to. Now wait a minute, we need to specify the size here. And store the position here. And then of course also the normal, get normals. And then we want to obj vertices, and clicks back that temp vex. And then we want to process the indices as well. Get indices dot size, and we we want to obj indices that push back all of our indices. Okay, and to our mesh offset, we push back let's see, we should always for the first mesh, we want to create 0. There we go. Let's see, let's try deleting all of this. And let's pass in the data here, and we want the size of this to be how many items we create. I don't suspect that we will allocate more than 8 kilobytes of data. We will run into trouble if we do. All right, let's delete the indices as well. And let's do our indices here. Let's see if this actually renders anything or if we messed up somewhere. Let's see. Whoops. Okay. We need to flip the winding order due to the thing being flipped here. Let's see. There we go. Everything looks fine. Okay. So now we load a box and we store the mesh offsets. And our pipeline is generally set up in terms of uploading more intricate meshes. So let's do some whoops, Blender stuff here. Can we actually do some are there any Blender text meshes? Blender text to mesh. Let's see. Okay, Blender text object. Shift A. Shift A. Okay. Let's see. Alignment, center. Um, DirectX 12. Is that just the name or is it the actual text? Huh. I think it's only the name here. Text boxes. Modeling. DirectX 12. How come it doesn't oh, let's see, DirectX 12. Okay. Extrude slider. Okay, let's see. We're in edit mode. What is the shortcut? Shift. Sculpting. Blender 3. Extrude slider. Oh, okay. It's in here. 1 meter. 0 to 25 meters. Blender, reset, viewport, camera. View align, center cursor. Okay. Let's rotate this around the yeah, and let's rotate this again. There we go. And the actual font itself. Do we even care? Do we even care? Okay. Let's try to export that. Let's see. So the okay. Let's see. Let's try exporting that. Waypoint legacy. Let's see, application models, B12 text, and the forward is going C forward, Y up, right normals, right materials, no triangulate faces. Let's try that. Okay. And let's see. D12 text. Won't be rendering all of it, but maybe let's see. We had some problems here. Error creating resource. Okay. Let's step through it. See what happens. How large? 2000 vertices. 2000 vertices. Let's skip that. Let's step into here. Let's disable that breakpoint. Okay. That works fine for some reason. What's the bug? It throws some error somewhere. The destination region extends past the into the destination resource. Okay. Let's see how many. Let's access the indices are far greater. Okay. Let's do a couple of megabytes here. There we go. Let's do 4 megabytes for our vertex buffer. There we go. Well, we of course do not render anything. Maybe we want to first off load our cube. Everything will be great then. And then we know load our RD12 text objects, and we of course duplicate this code here. We duplicate this code here and we offset by this size here. And we offset by this size here. We actually need to do this beforehand. We will store the offset for this mesh. We should probably move this up like this. So next mesh. Text mesh. That turned out perfectly, even though it wasn't intended. Let's see, and if we just look up our all right, I need to copy the shaders also. Model shaders. Replace everything. And then run it in NVIDIA inside here. Well, that's not what I expected. Oh, I haven't built it in release mode. Let's do that. Great stuff. Let's do some Resources, geometry. Well, we need to actually draw it, so okay. Let's swap our draw call. Did we store that? No, we didn't. So we need to store that. Let's just store that and remove the definition here. So now we have those. We push back the offsets. We want to draw the text here. So we need to do this call here. And of course we need to recalculate the next offset here. Otherwise we will know. So the last entry here will contain the values needed to calculate what to draw here. So let's mesh I offsets. And we have 3 entries, so it's the last entry minus the second entry, and 1 instance, and then start index location. It will be this, and the start vertex location will be this, and then the start instance location will be 0. Let's try doing that and see that if it works. It actually works. Okay, let's flip it 180 degrees and re-export it. There we go. Let's re-export it. C forward, Y up. There we go. View, viewpoint, back. Looking forward. Okay. Let's redo the application here. DirectX 12. Okay. We have a pretty fine draw call there. And we of course want to do it for our shadow. let's do a shader. Thing here. If the light direction maybe even black here. Yes, and well, we don't mind. Let's see. We also want to offset this, not in that direction. Let's see the object modifier. Where is that? Is it here? Location on the C is minus 0.1. That's too much. Well, let's just okay, and then in our render API here, we will set position of the first object here to be at a height of 0.1. Let's do a slower simulation. Excuse me. Okay, and let's do a tutorial. Ding export tutorial .obj. Let's load that. We apparently also want to end with that. Okay, let's do a second draw call here. Which will use this, except we will increase this value here. Wait a minute. There we go. Let's see. Does that work out? Oh, okay, we need more space in our buffer here. 10 megs. Let's do 10 megs. This needs to move down here because it's way easier to handle that way. Let's see. We can't create it. Let's see. Oh, the source. It's not the source. Or rather the buffers here. Let's do 5 megs again. And then inside our linear allocator here, of course, we need to slash. Let's do 10 megs of space. Okay. Let's see. Oh, we do this twice actually. That's why. And oh, wait a minute. I forgot that I moved it down here. So um, let's remove the skewing. Let's simply create this at the bottom here. And then raise this a bit. A bit, I said. And of course we need to do the same things for the shadows. Like this. Okay. Let's zoom a bit. Let's do 3. Let's rotate the angle a bit. Okay. Now that's the materials. The transforms here. Rotate normal. We will define the axis that we rotate around. We will rotate around the y-axis. I should always make a habit of putting the F here. Alright, and let's do 3.1 divided by 4. Okay. the temp data transform will be equal to our previous transform rotated by this rotation y times rotation y. And we want that in the opposite direction, so we do a -1. There we go. We have an angle here. Great stuff. We will limit our simulation, since we're trying to do a screenshot, to day and night, so we make sure we don't get any weird day and night things happening. And it moves sufficiently slow that we should we increase the brightness of our floor? We should at least expand it so that it is even bigger. Do we also want to increase the brightness a bit? Let's try doing that. Huh, did we mess something up? Let's try doing that. Well, it's not related to our shadows here. So let's set it back. Did we? For some reason that messes with our plane calculations. Maybe I can do 1500 here. Maybe we're happening to have problems with our far plane here. Yeah, let's maybe increase this to 200. 500. Maybe we want a bit less than 45 degrees. Maybe we want yeah, that probably looks a bit better, maybe even. So let's rotate it. Yeah. And then we should probably do some random mesh. Rebuild planar meshes. Do we have any of those? Free royalty. Oh, let's do itch.io. Game assets. View all tags. Let's do. Let's see, styles, themes, format, mix, royalty free. Characters, well, not exactly characters. No. Let's do 3D. Royalty free we will add later. FBX. Blender. Risk royalty free. Toon shader, maybe 3D. Oh, I can actually do tags myself then. Okay, game assets, 3D. Model. No. Okay. Object. Well. 3D. Okay, I can do Blender. 3D Blender. Royalty free. Can I do Toon? Cartoon. No. Uh, let's see this one. The cache. Well, I can't really display textures, so game dev the starter kit. C0 licensed. Okay. Okay, no attribution is required. I do though think that these models are a bit too sophisticated. It wouldn't do the author justice. Uh, well, maybe we could do some of these since they are low poly. Let's see. Uh, let's see. Licensing. And if we use this guy's stuff, we will add a we won't be using a lot of it anyway. Let me see. Let me do downloading here off screen. Extract it. Let's see. Shout out to this guy for reading a low poly pack. Let's see, obj fbx separated. Let's open the fbx. Console Nintendo. Well, that would probably be texturized, and we don't intend to. Can I actually see here? Okay. Mm, okay. Maybe we want to open the computer disk. Disk modern. Okay. All right, we will use the disk L here. Open with whatever. We will open it. Text. Open FBX. Okay, maybe we need to new general, delete that, import FBX. Yeah, we can do that. The disk model here. Let's view from the back. Okay, let's turn it around 180 degrees. Okay, and export that. Up, forward is that, and Y is up. There we go. Models disk. Great stuff. Whoops. And let's see. Door, gaming chair, PC case. Monitor. Okay, PC case and monitor will be the last things that we add to our project. Do we want that PC case or oh, let's see. Does this crash or what? Wait a minute. When this has some more details to it, so this will not look nice with our shading. I think this is the one. So PC case 1. FBX. PC case 1 here. And we of course want to view it from the back going forward. Whoops. Did we viewpoint back? Yeah. So let's see. That seems like it should be turned 180 degrees. There we go. Let's export that. Case. And I think we will have the correct settings. Yeah, we do. Okay. And let's decide on a monitor here. We have the curved one, which looks pretty neat. We have the flat one. I also have that one. Well, let's do the curved one because it's cool. And monitor curved. And let's see. We should flip this. No, let's see. If we view it from the back, we are fine here. Export that monitor. Great stuff. I think that should be our model handling. Let's delete this for now and look into our model stuff here. I'll move this off screen. I'll have to thank that guy later on. Okay. Let's load. Wait a minute. I actually think we need to do that to be able to offset the last one. So I think this is something that's, well, whatever, man. And we don't need to redo that. Let's do our desk here. Let's do our case here. And let's do our monitor here. Let's see if everything compiles and loads. Everything loads. We did load the models. Now we just have to draw them. Okay. So let's say that we swap the draw calls here. Let's do the desk here instead. And let me enumerate these. So our cube is 0. Our D12 text is 1. Our let's see. Soon I'll be done. I guess I'm a bit tired, so I just wanted to mess around with this, and maybe for the viewers, in case of in terms of the stream here, kind of like portray how to extend the whole pipeline here. And then we do like that, and then we have a sort of outline on what to do. And, oops, we're not going downwards anymore, we're going up, up, up. Okay, we do the desk here. Let's comment this out so that we need how to draw that. We know that this is a draw call for our second object. Let's store that, and let's do a draw call. We will draw a disk. So our disk is not our second object, but our third, so we need to add 2 to every index and offset. Let's do that, and let's copy this for the shader, or shadow, disk, shadow. Let's do that. And we have a disk. We actually want that disk to be flipped. We need to go down to find the object description here. So we will start by building our scene here. Let's rearrange the materials. Let's set the first material to be our shadow material. We will of course create the material up here, and then we need to shift this also set this, and let's set this to our desk material. What kind of material do we want, or color do we want our desk in? Well, I think something like a very dark gray desk would be nice. So let's arrange that. The material 1 is equal to our desk. Let's create a map here. Material 0 is equal to our yeah. In terms of doing memory mapping of matrices manually, it's pretty difficult. So just do whatever works, man. Maybe even use a library for the math. Okay, and we of course need to set this. There's our second material, and this is our third material here. We will redefine those later. It means that the way that the matrices are stored in memory is different in terms of their ordering. Do they do a whole row, or do they do a whole column as their first part of the memory layout? In shaders, they always do column major, but in the CPU side, DirectX Math does it row major. So that means that you basically transpose every matrix. Maybe you should look into the math behind it, because once you get the math and the actual memory layout stuff, it's quite self-explanatory. Let's see. I'm not sure what you mean by that. So let's see. Let's do our desk here. And we will have the material number 1 here. We will set our shadows to be our number 0 material for all shadows. Yeah, transposing is just basically changing between row major and column major format mathematically. Look up how to transpose a matrix and compare that how to store it in memory, and it will make sense. But you will use CPU cycles doing that, or even GPU cycles. So it's way more efficient to actually do things the proper way. So yeah, in order to reduce CPU and GPU cycles, you would prefer to store things the correct way the first time and not having to transpose it every frame or every time you want to do something with it. So it's easier for me at least, and in terms of efficiency, to just work with whatever the shaders do, and they always do column major, which means I think that the CPU side should also be column major, but you can do whatever you want. Maybe you don't want an efficient application, so maybe you don't care about that. The GPU can skip a whole cycle if it allows it to retrieve matrices that are stored in column major ordering. Alright, let's see. Our desk texture got applied. Okay, let's see. Let's set. Wait a minute. I think that we should offset this so that second is our floor here. Floor, and then this will be the desk. So let's see. Let's increase that, and we need to move down in order to find our materials here. Let's see. Let's clamp this into some model loading here. Model loading. So now we can close that scope. Update vertex and index buffers. Okay. Let's see, we do our materials here, then we want this to be our floor material instead, so we will move this into here and then move this up here. Okay, we have our desk model there. Okay, that's the materials. Oh, Visual Studio sometimes doesn't rotation. Why? Let's do 45, right? Isn't that 45? I think it's 45. Let's see, what's our problem here? Rotation Y undefined. Okay, yeah, because I missed it down here. Now that's 45. Let's do 135. So that would get that right. So the desk is our first object, right? Yeah, it is. Okay, but we want to reduce that a bit. No, that's just flipping it. Let's try. No, 3 doesn't work. Minus this divided by 2, I think. Or maybe just this. There we go. Okay, maybe we need the material of the table to be a bit more dark. Did we update the actual material? Or the desk here? So our floor is our second one here. Okay, that looks better. Okay, we need to then offset our desk here. Okay, our desk. And then let's move this up. Okay, the tutorial here is the next one. I think the next object should be our case. Let's see, our case, which we could do maybe, yeah. So our desk needs one increase here for every parameter. This is the floor. Let's draw the floor first, so we don't have to care about the objects. And then we create the case. The third mat will be the case. Material buffer number 3 here. Let's see, transforms. We have we could flip our table transform here. We have our table here. We will set that as our first one, or rather floor. And 0, 0, 0, then 1, then 2. Okay, let's redo that in terms of our mapping here. So we have trans 0 meaning floor. So we do object transforms for the floor here. Then the desk. Trans 1 is the desk, I think. Let's see, does that render correctly? And then the second one is the. Okay. So our floor gets set there. Let's see. Well, we bind it incorrectly. Let's see. We have our desk. So our floor has the 0 transform. Then the desk has the 1. And the second material, and then the case as whatever we have left. Let's make sure that everything works here. So this is our first one. 1. Disk. Case. Well, we have some problems here. Our floor, of course, needs to be drawn correctly. Let's see, our floor is our cube. So it will have minus 0, 1. This should render fine. But why do we not get the disk? Let's change it to the second transform. Okay. So there's a problem with the transform data itself. Maybe I need to maybe I missed something. So we set it for the floor to the, we don't need to do that actually. And then we copy our temp data, But down here we of course need to reset it. There we go. So that fixed it. Well, let's see. Maybe we want a bit offset on the X and Y here, or X and Z axis. Maybe that's way too much. Maybe we just want nope. We want it to be offset on the x-axis, I think, because we rotated afterwards. Yeah, we did. So let's do 2. That's too much. Let's do 1.7. Okay, and then a tiny bit on the z-axis. All right, great stuff. And what material would we like for our case here? Let's see, floor here. Floor. Desk. Case. Let's see, maybe we want a dark green case. Did we link the material? The desk case material number 3 friends number 2 equals case. Okay, we have linked that correctly. Let's link our objects to the shadow stuff here. So what we basically do is we do shadow transforms instead. Let's do shadows. And then we want like this. Like this. And I think these are ordered, right? Yeah, we do them ordered. Okay. Let's see. Okay, great stuff. For some reason... Oh, wait a minute, shadow transform here. Wait a minute. Did we mess something up? Let's revert back to the whole thing here. Trans to case. Well, we do not have any shadows. Why is that? Do we maybe need to increase the offset on the Y here? Nope. Somehow we lost it. Let's do 15. Let's do 15 here, or maybe just 4. Yeah. Well, no shadows are rendered. I messed up somewhere. Let's see the shadow material here, 0. It's our correct material. Oh, the floor is actually, yeah, that's why. We need to, when we do the shadow computations here, we need to skip the first one. We don't care about that one. And then of course we need to offset into the correct shadow transforms. These should also be, yeah, that's why. Okay, let's do the case here. And now we should have our shadows back. Great stuff. I think we want to adjust the position a bit. Maybe we accidentally changed the C value too much. And let's move this back up a bit as well. There we go. Maybe we moved the disk. Did we move the disk? Yeah, we did probably, didn't we? Let's see. Let's just do like that. Let's not look at things at an angle for now. Let's just look almost straight ahead. Maybe even 0.5. So let's raise it a bit. Okay. The desk is perfectly almost standing on the floor. Okay. This is why you want a level editor. Because iterations are so freaking slow this way. Anyway, let's do. That's too much. Okay, great stuff. Let's do a monitor here. Let's offset it a bit less on the X here. Yeah. And let's create a material for that. Monitor. Not floor. And let's do a dark gray here. And change that. Okay, let's do our draw call. Mat for monitor. Trans 3 monitor. Let's move this. Oh, we can simply just monitor. And let's increase these by 1. And then our monitor is also next in here. And let's draw the shadows. Case monitor. Yeah, we also did a bit of refactoring in terms of our material and transform indices, so that took a while. But now we kind of like have a drift on it. Okay. We want the monitor a bit more back. Also a bit less offset here. And a bit maybe less, I think. Yeah. Maybe we want the material of the disk to be a bit more reddish. And then maybe a bit of blue as well. Well, that's too much red. Let's do a bit like that. Well, that doesn't look pretty. Maybe no green at all. I actually do like that color. But then I think the case is a bit maybe it needs just a bit of a red tint. That starts to look like something of a color palette, right? Okay. Let's render our last object here. We want a material for the tutorial text. And we want a transform for our tutorial text. And I think we will create a, maybe we will just use that. Maybe we will just use that. Let's see. Nutrition 24. Let's do this instead, at least for now. So the tutorial text will have that. And we will draw our tutorial text, which will have our mat5 tutorial text and our transform tutorial text. Our tutorial text is number 2. Since our monitor was number 5, we have to go 2, 2, 2, and one more here. Okay, the rotation is of course not great. It's not what we wanted. We wanted rotation 45. Let's see. Oh, I might not have update. No. Number 4. Well, it's... Oh, I haven't updated the transform, that's why. And let's see, the material buffer also needs to be updated, of course. Okay, let's look into it. Rotation 135. That's not great. So rotation maybe just 90. Let's see. That's the problem. No, we want a weird one, or rather not weird one. Can we actually overflow this and do 270 by minusing this again? Let's see if it will allow us to do that. Maybe minus divided by 2. There we go. Then we want a scale here. DirectX. XM matrix scaling text equal to DirectX XM matrix scale. Let's do 0 0.5, 0 0.5, and then 0 0.5. Let's see. First, we need to scaling text. This needs to be done first. Let's see. I think maybe I need to do it in the opposite. Oh, 0 on the... no, that's right. We do scaling a bit less size here. Let's half it. And then let's offset it a bit higher here. And let's not do any of those right now. Okay, but let's still go in the opposite direction. Even more. And then a bit also on the positive direction here. Maybe the negative one here. But we need to go more on this one. No, it's not the negative one. It's more of the positive one. And we need to go even further here, so let's increase that. We would also like to go further here. Almost. Let's do 25 here. Maybe even 35. Maybe even 35. Maybe even 45. Yes, and we need to change the material as well. We want something. Obviously, we want something with a bit of a red tint since we're working in that space, but maybe we want something with a lot of blue here. Well, that's too green for us. Maybe also too blue. Maybe it's even too little red. Yeah, that maybe is a bit more what we like. Okay, let's do that for now. There we go, and we want to copy the transform as well. And we want to create it a bit higher on the y-axis immediately when we render the thing, and the tutorial text is actually after our DirectX 12 text. And we will increase this to number 5 and then number 6 here. Scaling text, okay. Maybe we want this to scale even a bit less. Maybe we want tutorial to be the biggest one. And then we need to offset it even more. I think we probably should double this. So let's see. 2.0. Because we have this size, so we probably need to double the offset. Maybe not. Let's see. Well, it seems that I was right. Okay. Although we do want to reduce the Y offset a bit. Maybe not that much. Let's see, let's create these shadows before we decide on anything. I think, yeah, these materials should be adjusted a bit. Maybe we even want a blue only color here. Yeah, maybe even a bit darker blue. Let's try that. And then let's create these shadows. And we will copy the text, did we? It seems like it. We will copy this and set it like that. Tutorial text, tutorial text. 5 and D12 text here. D12 text here. And did that work out? Oh. Okay, let's set the camera. Are we still looking at the origin? Yeah, we're looking at the origin. So let's get a bit further down here. Let's check out how that looks. Well, it looks pretty neat in terms of placement, and the actual visuals aren't that great. Maybe we do want a bit of an offset here. Well, maybe not that much. Also set a bit. Maybe a bit more. And maybe not that far away. Maybe even closer. And maybe we don't want to be looking at the exact origin, but maybe we want to look a bit higher. Okay. Maybe even a bit higher, and then move a bit more back. Well, that's a bit too high. And that's too far back as well. That's too close. A bit too close, not far away enough. Let's just reduce this to something like this. I do think I want to be a bit closer. Maybe even a bit closer. And then a bit lower here. And maybe we want something that is a bit more shiny in terms of how much light it reflects for our text here. That's the transforms. I think the transforms are good. Don't need the buffers there to be updated. I mean, what would suit this? Let's try white. I just want to try. Let's store this as a comment here. But let's try white. Just plain old white. I actually do like the dark parts of the scene. Let's see. Maybe we could render a bit more slow so I can actually consider my frame a bit more. Okay. This is really slow. Maybe we want something that is a bit faster than that. Let's double the speed. Let's see, I like the nighttime scenes, or early morning scenes here. Let me just be quick to grab a screenshot. Maybe I like the other angle better. Actually, I think I got an okay screenshot here. You can read the text. You can see the shadows. Yeah, I think so. Okay. I think that is it. We got ourselves our screenshot for the live streaming series. It feels good to be done with a project. Do I even have? No, I don't. Let's download. GIMP here. Mm. And let me just turn off the stream for just a sec while I install. That's fine. Let's try opening GIMP then. Let me just swap back here. Okay, let's see. Let's move it around. Okay. And let's do a layer here. Let's see. Okay, I can actually type text. Let's do a white text. And I actually think that we should move this. Oh, whoops, not that one. Let's lock that one. Can I lock it? Can I lock it? Lock layer. I need to Google that. Lock layer. GIMP. Okay. Did I just miss it? Lock position and color. Whoops. No. Lock pixels. What? Okay, now we can't move anything. Okay, that's great. Okay, add a new layer. No more. Okay, I think I might have created a layer group that is messing with things. Okay, part one. Let's expand this and underline, and can I set the, can I text to alignment over here? Let's see, let's move it. Part one, project setup. And we of course want to decrease the size here. And maybe even, whoops. There we go. But I would like to be able to expand it in the future. So Let's do like that, and then move it. Okay. Okay, that's a bit annoying. So let's do alignment here. And let's do 5, 5, maybe 50, 50. Okay, never mind. Or maybe distribute. Whoops. No, minus that. Okay. Also minus. Maybe even just 15, 15. There we go. I think that looks pretty neat. Um, thumbnail, prototype. And then export as part 1. Let's see. Let's just do default. And let me grab the playlist here. Also need to check whether everything is in order. Okay, we need 89 or 28, 29. That's actually 20. I'm sorry about that. Okay. So we need to change the name of that. Okay, 24 here. But we don't have 28 and 29. Oh, we don't have that many episodes. Alright. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times 2, 16, 17, 18, blah blah blah. Mm. Let's see, what's the format here? What's the relation? Which one? What? Divided by? That's not one, is it? We don't want to do that. Okay, 1.7 divided by 600, 1.3. Okay, let's see, 800 times, or rather 600 times 1.7. So 600 divided by 9 times 16. Yeah, we want the width to be that. Not preferences. Image, canvas size. 1070, no, 67. Resize. Okay, let's try moving this. Okay. And let's move this. There we go. Maybe we want to align this a bit further inwards, since we have so much of a margin now. Maybe even 75. Actually, maybe 105 here. Or even more. Yeah. 75. I think that has 180. Well, let's do 85 then, and things will be fairly aligned. Okay, I think that looks all right. Yeah, okay, so we save that. Maybe we want to move it a bit upwards since we are allowed to do that in terms of pixels. Yeah. Yeah, that looks better. Okay, let's remember to lock this and then export it. And let's re-upload the image. All right, that looks way better. Okay. Then we want the text here. Let's see. Okay. Part 2. All right, let's I only have to do this about 30 times. Hopefully it will be worth it. Okay, that's way easier. Okay, maybe I did a bit much spacing. Well, I'm not gonna fix that. It'll be a small bug that only me and some viewers notice. Okay. Didn't it work? Part 6, of course. let's do a let's see, at 0, and then do like this live stream. Live. I can't change the live stream anyway. Where was I? Okay, I was doing, oops, part 7 here, creating the swap chain. Oh, that's 8, cancel 7. Maybe I can even do it faster. I think I can do it faster. Let's see, sort by date. There we go, invert that. Okay. Let's do like this. Export part 9. Okay, 1/3 of the way. We simply just need to do all of this. I might as well fix up some of this stuff here as well. Part 11, yeah. Okay. Mm, 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 mm. 11.2 or 15.2 rather. Uh, uh, did I not? Huh. Oh, wait a minute. 15. Is part 15 missing? Did I delete part 15? Okay, I need to figure that out. Let's see. Let's see, and 14. Okay, I think I actually might have deleted part 15 or something like that. Let me see, when did we upload it? Maybe I have it in the storage here. Did I? Oh, that's not great. Okay. Oh no, it's on the list later. Okay, okay, okay. I was starting to get anxious. Okay. 16 here. Mm. Well, I guess it's caps or capital lettered. The word constant buffer, so we can do that. We do 18 here. Okay, we're almost done. Here was it. Video 1. Let's see. 90, whoops, 15.1, whoops. And I accidentally. Okay. Let's see. Let's see. Let me see. Okay, we're getting into the last third here. Alright, I'm getting into territory of the last 5 videos here. That's great. Let's see, I can't double enter that just to create it instantly. It's probably fine that it asks what to export as, because you would probably have a different pipeline in terms of doing a lot of these things. Maybe you would script it some way. Let's see. Whoops. That's an deprecated episode, so we'll be doing that. Now I've streamed the whole process of being a YouTuber. see. Okay, the last two ones. Whoops, we need to export that. And lastly, the last episode here. I really like the evening version. Even as a mood with the color scheme and everything. We might even do we could do a small game around that in the future. Let's see. All right. Last thing is that I need to credit my and then we of course need to credit the guy who did the stuff here. Is it this guy? No, it's not this guy. Let's credit him in all our videos here. Let's just do Great stuff. Let's make sure that this is correctly set up. Yeah, it seems like it. Let's do this one then, and this one then. Ah, whoops. Let's see. 420. Index buffer. Okay. Let's reset this. Uh, 14. All right, now he is credited on every video description. All right, I'll be going AFK for a while. Maybe I'll be back later on. Probably I should just end the stream. Since I think it's a wrap for at least this stream and series. Yeah, if you watch this in the future, hopefully you enjoyed it, and I hope to see you around on the channel. All right, take care.